Hello, everybody. We're going to learn about proving whether figures are congruent or not by using rigid motions. And this is section 3.2 in your geometry text, starting on page 127. So we'll start off with the definition of congruence. In a plane, two figures are congruent if and only if one can be obtained from the other by a sequence of rigid motions. And remember, rigid motions are reflections, translations, and rotations. So if there's any sequence of reflections, translations, and or rotations that map one figure to another, then the two figures are congruent, meaning they are exactly the same size and shape. So we see in example A, if you have some tracing paper, you could actually do this in your book. If you take some, maybe you have some wax paper or some other kind of tracing paper. If you trace over figure ABCD, we can see that all we have to do is slide that, and it fits exactly on top of HFGH. And so those two figures are congruent. We have the symbol for congruent is like an equal sign with a squiggly line on top. And so when we state that these two figures are congruent, we want to use that symbol, and we want to make sure the letters match up with their corresponding pieces. So if I say figure A, B, C, D is congruent to the next figure, I need to put the letters in the right order. So notice that point A ends up at point E, so that letter has to come first. B is the second letter. It matches up with F, so F has to come second. C matches up with G, so that has to come third, and D matches up with H, so that has to come last, so that we get the letters in the right order, indicating which pieces are corresponding to each other in the congruent figures. Okay, so we can say these are congruent since a translation maps ABCD to EFGH. And then we can do the same kind of thing in example B. This one I can't necessarily demonstrate for you with my tool I have here because I don't have a reflection tool, but you can see that if we put a line down the middle, if you do this with tracing paper, K would go to P, J would go to N, M would go to R, and that L would go to Q. And so if you trace this with tracing paper, you can just flip it over that dotted line, and you'll see if you trace figure JKLM, you'll see that when we flip it over that dotted line, it does land exactly on top of NPQR. And so our congruent statement would be JKLM is congruent to figure J goes to N, K goes to P, L goes to Q, and M goes to R. Since a reflection maps JKLM to NPQR. So a reflection is a rigid motion, and so that's how we prove that they're congruent. For example, C, this figure gets smaller, and so there must be a dilation. A dilation, remember, is not a rigid motion because the distances are not preserved. And so these figures are not congruent. They may be the same shape, but not the same size. So we say LMN, triangle LMN is not congruent to DEF, triangle DEF since distances are not preserved. Okay, and so then we'll go on to page 128. And they did a similar example in A, but now it's on a coordinate grid. And so we can actually use coordinates and formulas to prove that these are congruent. And so this figure is a reflection, just kind of like the example B that we did up above. If we reflect across the y-axis, these figures match up perfectly. And so they used the reflection across the y-axis where the x-coordinate changes sign, but the y-coordinate stays the same. And so we can show that this reflection maps figure CDEF exactly onto JKLM. And so then we could say CDEF is congruent to JKLM because a reflection maps one to the other. Okay, and so go ahead and pause your video and see if you can figure out if these figures are congruent and by which transformation. So these figures appear to be the same, and it is a rotation that will get you there. If you can see that that's a 90-degree rotation clockwise, or you could do a 270-degree rotation counterclockwise. So you can map this by rotating about the origin 90 degrees. This is a rigid motion that maps one figure to the other, so the two figures are congruent. The coordinate notation for the rotation is, let's see, if we look at a point like Z was at 1, 2, and it ended up down here at point C, which is 2, -1. So we see that that is XY gets mapped to Y -X, and that is a rotation. Okay, now go ahead and pause your video and try number 2. Okay, number 2, you can reflect across the x-axis, and these points will match up perfectly. Going across like that, just by folding your paper on the x-axis. And so we can say figure ABCD is congruent to, let's see, A matches up with W, B matches up with X, C matches up with Y, and D matches up with Z, since a reflection maps ABCD to WXYZ. And the transformation is XY gets sent to X -Y. The X values stay the same, but the Y values are opposite in sign. Okay, and then we'll do some more of these, but now it might take more than one transformation. It might take maybe a rotation and a reflection, or a translation and a reflection, or something like that. And so here in example A on page 129, we see that we can do a 180-degree rotation about the origin that would move the figure to here, and then we need to move, we need to slide the figure to the right by 1 unit. So notice that the units on here, they did each line on this grid is 2 units, and so it's actually shifting only 1 unit. So if I just slide this 1 unit to the right, it lines up perfectly. And so it takes a 180-degree rotation followed by a translation 1 unit to the right. So this is the algebra for the rotation. This is the algebra for the translation. And so this time, pause your video and try number 5. You're looking for a sequence of transformations. It could be 2 or 3 different motions that you have to do to get one figure to the other. Or if it's impossible, if you trace it with tracing paper and it's impossible to turn it or flip it or slide it to make one land on top of the other, then maybe they're not congruent. So pause your video and try this one. Press play when you're all done. So this mapping, if we start with the figure on the top, if we reflect across the x-axis, it goes to here. And then we just need to slide it over to here. Okay, so so we can say here's our congruence statement that's already given, and so we can say reflect across the x-axis, then translate looks like 2 units to the left and 1 unit down, or actually these are each of these boxes is 2 units, so we're going to translate 4 units to the left, so 4 left and down 2, because again each box represents 2 units, and so the reflection is going to be x negative y, and then the translation is going to be x minus 4, y minus 2. Okay, now try the same thing for problem 6. Pause your video, and then press play when you're all done. Again, some tracing paper may help you figure out how to get from one to the other in this case. So this one might have been a little bit harder to figure out how to get these to match up. One key is that this segment BC is the only segment there that is 1 unit long, or not 1 unit, but 1 unit diagonally, so over 1 and up 1, and our Q matches up with that. And then this segment ED looks like probably the longest one, and that matches up here. And so in order to get these to match up, we need to first reflect across the y-axis. And so when we reflect, point B goes here, point C goes here, point E goes over to here, and point D goes to here. And so now we have the figure is looking the same, and so now I would just need to take that figure from there and slide it down. Oh, did I miss a point? I didn't reflect point. Let's see, E went over to here, and C, what point am I missing? 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, let me start over. B prime goes there. Oh, I think it was A prime that I was missing. Okay, C went over to here, and E went there, and D went there. Okay, now I have all 5 points. And so now if I take that figure and slide it down here, it matches exactly. And so that's just a translation after that. So first it's a reflection across the y-axis. That would be xy gets sent to negative x, y. And then we translate straight down. Let's see, it's by 2's again. So it's easiest if we look right here at this point. B goes down 2, 4, 6, 8, 10. So translate down 10. And so that's going to be x, y gets sent to x, y minus 10. And so those are the two transformations that map one figure to the other. And that's it for today's lesson. Have a great day.